So today we're going to do what's called transformations, and to help us out, we're going to take this, what we call parent function, y equals x squared. We're going to start moving this thing around, going up, down, left, and right, stretching it, all this stuff, okay? So as we take a look, it says graph using a table. It says complete the table. I'm going to start right there at 0, and I'm just going to plug it in. What is 0 squared? 0, so I got to graph the point 0, 0. Okay, that's right there. And if I go and plug in 1, what's 1 squared? 1. And if I plug in -1, what is -1 squared? 1. So we get -1, 1. Again, we talked about graphing these before. Over 1, up 1, over 1, up 1. And then we do 2's. What's 2 squared?
4.
4, and we get 2, 4. And if I square a negative, you better get +4, -2, 4. So over 2 from the vertex, up 1, 2, 3, 4. Over 2, up 4. And if we do 3's, we know 3 squared is 9er. So we get 3, 9. And when we plug in -3 and square, we get a +9 also. So over 3 and then up 9 boxes. Over 3, up 9. And you could do that all day long with a quadratic. Just keep squaring whatever you go over. You can get a nice, pretty graph. Arrows on the end so that you know that I know that I know that you know that you know that I know that I know that you know that it goes on forever, ever in that direction. Okay? Now, this is what we call the parent function. Everything's going to be derived or come from this function. We're going to start moving this guy around. Okay? And we had some questions down here. What shape is this guy? What do we call that? Jack? Probably a parabola. That's how you spell it. Parabola is how we say it. And what do you notice about this shape? It's a U shape. And I would always say it's symmetric. Dun, 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 it's symmetric. What is this, the point called where it changes direction? What is this guy called? That's the vertex. And that's also known as a minimum or maximum. So this vertex, is this the lowest point or highest point on the graph? That's the lowest. So in this case, it's a minimum. Or min for short. Okay. So what do you notice on both sides of that point? So what do you guys notice? Yep. It's symmetric. Yep. It's same on both sides. So, and what makes number 5 possible? How is it the same on both sides? What gives you the same y values? Yep. Yeah, when you square something, right? Anytime you square something, and this says symmetric, sorry, the R and I kind of got smooshed together. Anytime you square something, you square a positive, you square a negative, you'll always get a positive back out, right? So when you square a plus or minus, you'll always get a plus, which is going to keep it symmetric, okay? Domain, the domain of this guy is what we call all reals, the fancy R, or goes from -infinity to infinity, and your range, bottoms up, how low does it go? Does it go down low, down to the flow? Goes to 0, right? That's part of your graph, so we have a bracket on 0, and how high does it go? Does it go up high, all the way to the sky? You betcha. It's all the way to infinity. That's why we have arrows on the ends. So this thing goes from 0 all the way up to infinity. This thing goes all the way to the left and all the way to the right. You can plug in any x value, and you should get a y value back. Okay. So there's a little box in the bottom. I'll kind of read through this. Quadratic function is a function that can be written in this form. We've got y equals ax squared plus bx plus c. And this is called standard form. Okay, that's standard form. The vertex is the minimum or maximum point where the parabola stops going down and starts going back up, or vice versa. So that vertex is a min or max. So we're going to start looking into that. We've talked about axis symmetry. That's the line that cuts through the vertex. And if you recall, that vertical line is an x equals line, an x equals equation. So example, if we have a vertex at 5, -2, then the axis symmetry would be 5. It's, again, the x value of your vertex. Before, in the last section, we would find that axis symmetry and use that to plug in to find the vertex. Well, now we're going to actually find the vertex first and use that to find the axis of symmetry. Okay, so let's get moving and grooving here. One of the first things you guys should be able to do is take a look at your graph and identify the vertex and decide if it's a min or max. And then also we should be able to find the axis of symmetry. Now, when I had these originally, they got shifted from what it looks like on the computer and what it looks like when I printed it out. So I want you to assume that that vertex is right there, because whatever happened, it kind of got shifted just a touch. So make these vertexes nice and big right there on that point right there. All right, so the first thing is we need to point out a vertex here. So if I count from the origin and I count 1, 2, 3, that's -3. And then I count down 1, 2, that puts me at -3, -2. Now, is that a minimum or maximum? Is that the lowest point or highest point on the graph? Okay, that's a min. That is the lowest point. Perfect. And then last but not least, the AOS, axis of symmetry for short, is AOS is what I use. That is an x equals line. So that line goes right through that vertex right there at x equals what? -3, very good. Okay, we're getting that number there from this guy right here. So we're kind of going backwards now. We're getting the vertex first and then coming up with the axis symmetry. So when we take a look at number 2, we got to come up with the vertex given the graph. So if I count over 1, 2, count up 1, 2, 3, 4, 5, 6, I'm at 2, 6. Is that a minimum or maximum? That is the highest point. That's the top of the peak. That is a max. And then last but not least, this is going right through, cutting it in half, and that's at x equals 2. So AOS for short. Okay, so again, we're kind of going backwards now. We're using the vertex to come up with that axis of symmetry. That's easy, right? You can do 9-1, 9-2 pretty easy. Right. Well, now we're going to see a different form. Before we saw everything in standard form, now we're going to see everything in what we call vertex form. Vertex form looks like this. It says y equals x minus h quantity squared and then plus k. So our vertex is going to be what we call h and k. Okay, so it's asked us to determine the vertex, axis symmetry, domain, or range, and decide if we have a minimum or maximum. So as we take a look, if I just covered up this +3, I have, let me zoom in so we can see this nice and big here. I've got just y equals x squared. So we're going to take that parabola, and now we're going to add 3 to everything. What happens with this k value, this guy right here, moves things up or down. Okay? If you see a positive number, it's going to move everything up. And if you see a negative number, it's going to move everything down. So if I look, I have y equals x squared plus 3. Is this moving it up or down? I'm getting the finger. No, the index finger. Okay, everything, people are doing this. It's going to move it up. This is what we call a vertical shift. So our vertex was at 0, 0 for the original graph on the front page of our notes, and now it's getting moved up 1, 2, 3 units to 0, 3. So our vertex has now been moved up 1, 2, 3 units. And now it follows that same graph. If I graph the parent function, I like showing you guys this guy. So on the front, we had y equals x squared. That's 0, 0, 1, 1, 2, 4. Looks like that. And it's symmetric. I'm going to do a dashed parent function here. Well, now this whole parabola is just moving up 3 units. This whole parabola is just shifting up 1, 2, 3. So the idea is this point right here at 1, 1 has now been shifted up 3 units. 1, 2, 3. Up 1, 2, 3. What I always remember is follow the basic pattern of a quadratic. Over 1, up 1, over 2, up 4. 1, 2, 3, 4. It's symmetric. So now this is what my new parabola looks like. Okay. All right, this guy does have an axis symmetry. The axis symmetry is 0. Goes right through it. That's our AOS. And you know your domain and range, right? Domain, fancy R, or negative infinity to infinity. And what's your range? What is it? Yeah, it starts at what y value? What's this y value of the vertex? That's 3 and goes all the way up. Okay, so last but not least, min or max. This guy is a minimum. All right, let's take a look at number 4 before we leave for today. As I take a look, I got y equals x squared minus 3. This does the opposite. If I have a positive, it moves up. If it has a negative, it goes down. Okay, so here's the idea. Y equals x squared is our parent function. 0, 0, 1, 1, 2, 4. Just trying to give you a visual on what's going on with this parabola. Here's the original graph. And now that whole parabola is going down 3 units. So your vertex is normally at 0, 0, and now it's down 1, 2, 3. Your vertex has now been moved to 0, negative 3. Everything now gets shifted down. 1, 2, 3. 1, 2, 3. Or what I'll do is instead of using the parent function, I just know what it's going to happen. From the vertex, over 1, up 1, over 2, up 1, 2, 3, 4. 2 squared is 4. Very good. Looks like that. That is, again, a minimum. So we should be able to tell if that's a maximum, and that is the lowest point. And then you should know your domain and your range. Domain, all reals. Fancy R, if you want to do it this way, negative infinity to infinity. Either one, quiz or test, I would accept. Range, how low does it go? Does it go down low, down to the flow? No. What's this y value? -3. Goes all the way up, never stops, goes to infinity. So again, I'm getting that value right there from my vertex. Today we're going to zoom in on the h value. That h value is going to be moving it side to side now. Okay, again, we said it's always opposite of what you think with the h value. If you see a positive, it actually moves it to the left. And if you see a negative, it actually moves it to the right. Okay, so as I take a look, I've got example 5, I've got y equals x plus 3 quantity squared. Which way does it move it? Right or left? Opposite of what you think. This is really x minus a -3. It moves it, and Gail's pointing to the my right, your left. Very good. This thing is moving left. Okay, so I'm going to take my vertex, and I'm going to move it over 1, 2, 3. My vertex is right there. At -3, 0. Now it's going to follow the pattern of a quadratic. The pattern is from the vertex, over 1, up 1. Over 2, up 4, because 2 squared is 4. 1, 2, 3, 4. Good with that? So again, over 1, up 1. Over 2, up 4. There's also that axis of symmetry now. It's symmetric. That's at x equals -3. And if you have 2 points on the right, we can reflect those guys over and get the 2 points on the left. Dun, 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 dun. It's symmetric. So it follows that same pattern, over 1, up 1, over 2, up 4. Okay. At any point, you guys want to use a table, you could use a table. Don't have to if you know the pattern. Okay. Any questions? Is that a minimum or maximum, y'all? This is the lowest point, and I heard somebody say that's the min. All right, so we have, again, determine vertex, x symmetry. We need domain and range. Domain, range. What's your domain and range here? Domain is always what? All real numbers. You can do -infinity to infinity or the fancy R, either way. Range is the lowest y value to the highest one. How low does it go? Does it go down low, down to the flow? No. Starts right here. What's this y value? What is it? 0. Gail's giving me the 0 look. And it goes all the way up, never stops, all the way to infinity. Doing all right? Opposite of what you see in parentheses.
The domain is what it covers the x-axis, and range is what it covers.
Right. So domain is left and right. How far left does it go? Just goes and goes and goes to -infinity. Goes all the way to positive infinity on the x-axis, right? And then range is how low to how high it goes. Oh, good. Danny.
So whenever you get a 0, do you always put a bracket on it?
For range is always be inclusive of our graph. So this -3, 0 is part of our graph, so it's inclusive. It's part of the graph. That's a bracket. So good question. So range will always have a bracket. Always, always, always. When we're looking at infinities, those always get parentheses. All right, here we go. Next one. Well, now we just do the opposite. This time I've got y equals x minus 3 quantity squared. Which way do I go? I go right. So I go right. As I take a look, I count over. 1, 2, 3. There's my vertex. Okay. Axis symmetry goes right through that at x equals 3. Now we graph the rest of the points. If you want to use a table, plug in 4, plug in 5, see what you get. Or just follow the pattern. The pattern is over 1 up 1, over 2 up 4. The reason I'm doing that is because 1 squared is 1, so that's over 1 up 1. And then 2 squared, 2 times 2 is 4. That's why I'm going over 2 up 4. It's symmetric. So perfect. All right. Domain and range would be exactly the same as the other one. All right. Any questions with that? All right. So last thing we need to do is talk about this guy right here, number 7 and 8. You guys good with 5 and 6 today? 7 and 8. Now we have this a value. This time we've got a is 3. That's a positive, so if it's a positive, then smiley face. Negative, frowny face. So again, if a is greater than 0, smiley face. If a is less than 0, we talked about that's a frowny face. Can you guys see the eyes, the nose, and the mouth? The inequality sign. All right. Now this thing has no h and k, so my center, my vertex, stays right there at 0, 0. There is no h value, there's no quantity there, and then there is no k value at the end of this thing. So this thing stays at a vertex of 0, 0. And that axis of symmetry stays at x equals 0. Now, when we graph these things, I always ask you to come up with at least 3 points, a vertex, and then one on the left and one on the right. So now we got to come up with at least 1 point on the right and 1 point on the left. Yeah.
Why is it 0?
Axis symmetry, this guy, because it goes through the vertex. Right. In our last other set of notes, we asked you to come up with the axis symmetry and then use that to come up with the vertex. And now we're coming up with the vertex, and then we should know the axis symmetry. And that number I'm getting, Jet, and this is a great question, I'm getting that from that x value. So this x value here. Okay. All right. You good with that? All right. Well, this is where, if you need to, you can make a table or understand what the a value does. We showed you on the sliders before. If the a value is bigger than 1, what's happening to my graph? It's getting stretched vertically, right? It's getting really, really thin, getting compressed. So what's happening is this graph is now growing and growing and growing. So instead of going over 1 up 1, you're going over 1 up 1 times 3. What's 1 times 3? That's 3. So that's over 1 up 1, 2, 3. You go up your a value. That's like a multiplier to that value. So over 1 up 1 times 3. Normally we go over 2 up 4, right? Over 2 up 4. Well, now it's over 2 up 4 times 3. What's 4 times 3? That's 12. That's off the chart. It's off my graph. So when you graph these with the a value, only need 3 points. The vertex, and then 1 on the left and 1 on the right. And what you'll see is this thing just grows super fast and looks super skinny. Okay. Now, table. Some people like to use the table. That's totally fine, especially when there's an a value. So again, we have y is 3x squared The first integer we plug in is 1, right? That's 3 times 1 squared. 3 times 1 is 3. That's over 1 up 3. Okay, does that make sense? And if you plugged in 2, you'll see, if we did 2, that's 3, and then 2 squared. Well, 2 squared is 4. That's 12. That's way off the chart. That'd be 2 comma 12. That'd be too far. Okay, so over 1 up 1, and then times your a value. So that's over 1 up 1 times 3 is up 3. Okay. Any questions? Domain and range, min or max. Is this a minimum or maximum? Lowest or highest? That's the lowest. So we would call that vertex. That would be a min. Domain and range. Domain is always all reals, negative infinity to infinity, or the fancy R, either way. And your range is your lowest y value to your highest. What's your lowest y value? 0 is your minimum. It goes all the way up. Okay. Let's do one more. Let's finish up number 8. Any questions on 7, y'all? No questions. All right, number 8. Do you see an H or K value? Do you see an H or K? Will, H or K? Nothing. Your vertex is not moving. It is staying there. 0, 0. Okay, so your vertex stays at 0, 0. That means your axis of symmetry is what? Straight through that vertex at x equals 0. Very good. Well, this time I've got an a value. And that a value is negative 1/3. And if it's negative, Gail's pointing down, frowny face. We got a frowny face. Oh, man, nobody likes frowny faces. Oh, man. That just means instead of going over 1 up 1, we'd be going over 1 down 1, and then times our a value. What's our a value? What do we have again? Negative 1/3. So I'm going to go over 1 down 1/3 of a box. 1/3 is right there. Over 1 down 1/3. It's right there. Okay. This thing is again getting flipped upside down. That's why it's negative. And then it's getting compressed vertically, which means it's going to look a little wider. So if you wanted to look at a table here, so you can see what's going on, plug in 1. We're plugging that into negative 1/3 x squared. That's negative 1/3 1 squared. Well, that's 1 times negative 1/3 is negative 1/3. So 1 comma negative 1/3 is right there. And then it's symmetric. That one's going right there. Look at what happens when you plug in 2. Okay. Plug in 2. I get negative 1/3 times 2 squared. Well, what's 2 squared? That's 4. I get, well, make that a 3, not a 2. Got 2's on my brain. That's negative 1/3 times 4, which is negative 4/3. Well, negative 4/3 is like negative 1 and 1/3. That's over 2 and down 1 and 1/3 of a box. So over 2 and down a little bit past the box. Normally I go over 2 down 4, right? Well, now I'm only going down 1 and 1/3, or negative 4/3. Over 2 and down, right? You can see how wide this thing is getting now. Something like that. Arrows on the ends, continues on. Okay. I do ask that you graph at least 3 points of vertex and at least 1 on the left and 1 on the right. If you can graph 5 points, makes it even better. Okay. Any questions on what's going on with this graph? You guys, are you able to see this? I can zoom in a touch if you need to see this guy here. So again, I plugged in 2. 2 squared is 4. Negative 1/3 times 4 is negative 4/3, or 1 1/3 negative. Okay, let's talk domain and range. Domain obviously is all reals. Negative infinity to infinity. In your range, bottoms up. How low does it go? Does it go down low, down to the flow? Faux show. It never stops, right? It just keeps going and going. That thing goes all the way down to negative infinity. How high does it go? Does it go up high all the way to the sky? It stops right here. This y value stops right there at what, 0? Okay, this is an example where your graph got flipped upside down, which means your range gets flipped. Okay, if I zoom out, if you look on this side, it's 0 to infinity, and because this one has been flipped upside down, now it's negative infinity to 0. Okay, so guys, you've seen everything I can show you in terms of H and K and your A. Now it's just practice time. Okay, do you guys have any questions on notes?